Okay, now one of the things I did forget to tell you is in your textbook you have the definition of infinite limit on page 65 in a box. You also have the definition of one-sided limit in a box on page 65 as well. You also have the definition of vertical asymptote. Remember that it's an x equals equation. And then we can continue on with our notes. So in this particular problem, you have the limit as x approaches 3. So we're going to plug 3 into the function. If I plug 3 into the top, I get 8. And if I plug 3 into the bottom, I get 0 squared. So that means you have 0 on the bottom. 0 on the bottom means your answer is either negative infinity, positive infinity, or does not exist. So the way that you work it, of course, is you plug in values to the left and to the right. Because you know it's either going up or down, you have to see where it's going. So I'm going to start on the left, choose a different color. So when I start on the left side of 2, on the left side of 3, I would choose 2. So I'm going to plug 2 into this function. So I would get 2 plus 5 over 2 minus 3 squared. So that would be 7 over negative 1 squared, which would be 7 over 1. I do not care about the value, I just care about the sign. So this answer would let me know that I have a positive result. That means it's going to go to positive infinity. I will then plug in on the right side of 3. Something on the right side of 3 that I might choose is 4. I will plug 4 into this expression. 4 plus 5, 4 minus 3 squared. That would give me 9 over 1 squared, which would give me 9 over 1. I could care less that the answer is 9 there. What I care about is that it is a positive result. Positive result means that it's going up. Now then, once I plug in the left and the right, I have to decide, do they meet? Are they going in the same direction? In this particular case, yes, they do meet. They're both positive infinity, so that means your answer is positive infinity. And that's how it would look. Now then, so we've got a couple more of these we'll run through. Obviously, I've done a good many examples. Okay, at this first one, we have x goes to 1. So just running through that one kind of quickly. When I plug in 1, I get 1 over 1 minus 1 squared. So that would give me 1 over 0. Okay. The first thing I would do is plug in something on the left side of 1. So on the left side of 1, I might choose 0. Okay, if I plug in 0 here, I get 1 over 0 minus 1 squared, which would be 1 over negative 1 squared, which would be 1 over 1, which is a positive result. And a positive result means it's going up. I would also need to choose a value on the right side of 1, and a value on the right side of 1 would be 2. So if I choose 2 here, I get 1 over 2 minus 1 squared. So I follow that along, and I get another positive result. And a positive result here means that I would get positive infinity. As you notice here, they do match. So my answer would be positive infinity. Okay, my next one's a trig one. So we want to take the limit as x goes to pi over 2 of secant of x. Now the easiest way for me to explain it is to change secant to cosine. Not straight cosine, of course, but secant is 1 over the cosine of x. When I plug in pi over 2 into this trig expression, I get 1 over 0. So 1 over 0 means it's either going to positive infinity, negative infinity, or does not exist. Now, just like in the other ones, I'm going to pick something on the left side of pi over 2 and on the right side of pi over 2. Now, there's lots of easier ways to do it, but I'll just explain it the best way I can. Okay, here's pi over 2 right here. So I'm just going to pick some angle in here. I might choose pi over 4. Okay, so I'll plug that one in. And of course, pi over 4 here, let me change it to green. That's how I've been doing. Pi over 4 would be on the left side Let me pause it just a second. Okay, as I got in the middle of that, I thought the left and right's going to be a little shaky. So I'm going to explain this a different way. I'm scared left and right will confuse you. So let's start back over with it. Secant is 1 over cosine. So when I plug in pi over 2, I get 1 over 0, which is either negative infinity, positive infinity, or does not exist. So I have to plug in something on the left side of pi over 2 and the right side of pi over 2. So you have to remember how you graphed these, although I'm not going to make you graph it, but you have to remember how you graph these in your trig class. Okay, here's pi over 2 right here. I'm going to have an asymptote there because that's what made my denominator 0. So I need to pick a number on this side of pi over 2 and a number on this side of pi over 2. It can be any angle you want. So I know over here an angle that I like to use is 45. So that's pi over 4. So that's what I'm going to choose on the left. On the right, I can choose pi over 4 in that quadrant. So let's put them in terms of common denominators. Pi over 2 is actually 2/4 pi, because remember 2 over 4 is the same thing as 1 over 2, so that's what that one would look like. So if I was picking something in this next quadrant, an angle over here that I could choose is 3 pi over 4. Now let's talk about cosine for a second. Cosine of pi over 4, that's what I picked. Pi over 4 is 45 degrees, so that's 1 and the square root of 2. So I know the cosine of pi over 4, any reference angle, would be 1 over the square root of 2. Okay, from 0 to pi over 2, that's quadrant 1. In quadrant 1, everything is positive, so that means the cosine is positive, so that means it would be going up. In quadrant 2, that's between, here's quadrant 2 over here. In quadrant 2, I know that the cosine is negative. So that means I'd have a negative value over here. Since on the left it's going up and on the right it's going down, my answer for this one is does not exist. Now let me go over one more of those because that was really confusing. Let's try another one. I think in our last section I gave you this one. And I kind of worked it a little early, so let's start back over with this one. Okay, tangent of pi over 2. If you put that in your calculator, you would get that it's an error. But I can explain it better by plugging in this way. Tangent is sine of x over cosine of x. So if I plug pi over 2 into this, the sine of pi over 2 is 1, and the cosine of pi over 2 is 0, and so 1 over 0 would either give me positive infinity, negative infinity, or does not exist. So what I have to do with this one is plugging something on the left and right of pi over 2. Okay, so something on this side of pi over 2, let's put an asymptote there. Okay, something on this side of pi over 2 that I could choose would be pi over 4. And something on this side of pi over 2 that I could choose would be 3 pi over 4. And I got that remembering that pi over 2 is the same thing as 2 pi over 4. So that's why I picked one on the left and one on the right. Now, I also know how those behave in quadrants. This is quadrant 1. That's between 0 and pi over 2. Okay, so between 0 and pi over 2, I know that all items are positive. Okay, now quadrant 2, what I have is from here to here. So that would be from pi over 2 to pi. So that would be this area here. In this quadrant, I know that the sine is positive. I know the cosine's negative, and I know in this part that the tangent is negative. So if I look up there, I know that the tangent is positive on this side, the left side of pi over 2, and I know that the tangent is negative on this side, so I know they do not meet, and my answer is does not exist.